Hello, everyone. Sorry for that delay. We had a couple phone calls we had to take care of here in the office, but thank you for attending today's webinar on PoE Ethernet, Modbus TCP data acquisition modules. Thank you again, everyone, for attending. My name is Colin McLeod. I'm from our marketing department here at ICPDAS. I've got Steve from the technical department with me on the call today. So today's webinar will take the form of a presentation followed by a question and answer session. If you have any questions that come to mind during today's presentation, please enter them into the chat box at any time and we'll try to get to them all at the end. Today's discussion is going to be about the unique advantages of using Ethernet and PoE for data acquisition. Let's take a look at the agenda. Today's discussion is going to be about the unique advantages of using Ethernet and PoE for data acquisition. Then we will get into some specifics about high-speed data logging, which will provide us a nice transition to talking about the features of our PET7H16M high-speed I/O module. And then finally, we'll discuss an example of how high-speed data logging works in the field. Again, my name is Colin, the newest member of the ICPDAS USA marketing team and the one with the golden pipes. We've got Steve here, one of our engineers, and he is here to answer your more technical questions at the end. Before we begin with the webinar proper, though, I'd like to give you just a little background on who we are and try to establish our bona fides a little bit. ICPDAS is a data acquisition and industrial controls manufacturer established in 1993. Our headquarters is located in Hsinchu, Taiwan. We have offices in Taiwan, mainland China, Europe, and of course, good old US of A. ICPDAS USA was launched in 2001 right here in Lomita, California to support the North and South American markets. We have over 200 R&D engineers. We work closely with them to add new features to all of our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning they're lead-free. We also have our ISO 9001 certification, which ensures we meet product statutory and regulatory requirements. So today's discussion will concern three broad topics: data acquisition with industrial Ethernet, Modbus TCP, which is an Ethernet protocol, and PoE, which stands for Power over Ethernet. A little background. Data acquisition is the process of sampling real-world physical information and converting those samples into digital numeric values that computers and controllers can understand. We use remote I/O modules like the ones we'll describe today as an intermediary between sensors and computers. Analog sensors measure a lot of different things: voltage, current, strain, frequency, etc. In order to turn this analog information into machine and human readable data, the data acquisition module, like the ET7202 module you see in the picture, that module takes samples from analog signals at a predetermined interval and converts them into a digital signal that controllers, data loggers, and computers can read and store They convert it into a signal that computers can read and then store digitally and then display for other uses. They turn it into manipulable data that people can use. Industrial Ethernet is the use of Ethernet in an industrial environment with protocols that provide determinism, and real-time control. Protocols for industrial Ethernet include EtherCAT, Ethernet/IP, Profinet, PowerLink, Circos, CC-Link IE, and Modbus TCP. Today, we're going to be focusing on Modbus TCP, and we'll be talking about that in just a sec. When it comes to choosing a network for your device, Modbus TCP/IP offers several significant advantages. We're going to discuss them in the following slide. Finally, Power over Ethernet describes any of several standard or ad hoc systems which pass electric power along with data on twisted pair Ethernet cabling. This allows a single cable to provide both data connection and electric power to devices to all the devices on your network. So Ethernet for data acquisition has a number of advantages, such as standard reliability, easy installation, long transmission distance, and fast transmission speed. Its openness and popularity are not only widely used in the integration of IT, enterprise, and field solutions, but has also become a mainstream specification for industrial communication. So Modbus TCP is the Ethernet protocol that we'll be discussing today, and Modbus TCP is actually integral to our high-speed data acquisition modules, and it offers a number of advantages. Number one of those is simplicity. Modbus TCP simply takes the Modbus instruction set and wraps TCP/IP around it. If you already have a Modbus driver and you understand Ethernet and TCP/IP sockets, you can have a driver up and running and talking to a PC in just a few hours. Development costs for Ethernet are very low. Minimum hardware is required, and development is easy under almost any operating system. Another advantage is that industrial Ethernet data acquisition just uses standard Ethernet cable. There are no chipsets that you need. You can use a standard PC Ethernet card to talk to a device. As the cost of Ethernet falls, you benefit from the price reduction of the hardware. As the performance improves from 10 to 100 megabytes, soon to 1 gigabyte, your technology moves with it, protecting the investment in your infrastructure. Also, Modbus TCP is an open protocol. It was originally developed by Schneider Electric, but is now governed by the Modbus organization. This Modbus TCP spec is available free of charge for download. There are no licensing fees. Again, it's an open protocol. Another advantage of Modbus TCP is that interoperability among different vendors' devices and compatibility. The large installed base of Modbus compatible devices makes Modbus a very good and flexible choice. So this is our high-speed data acquisition Ethernet module, the PET7H16M. And this device offers a number of advantages over a serial solution. For instance, at present, most of the high-speed synchronous data capture systems are collected by a computer host with data capture cards. And when the number of channels increases, more data is needed to capture on the card. If the devices to collect data are distributed across multiple sites, you'll need to increase the number of computer hosts. Right now, the PET7H16M is used instead of this configuration of computer and data capture cards. The data collected from different sites can be transmitted to the central monitoring computer through the network, which can greatly reduce the complexity and time cost of wiring infrastructure, and has the advantages of offering real-time monitoring. PET7H16M can be used for continuous data acquisition, high-speed interval acquisition, and simultaneous acquisition with multiple channels. The maximum speed of each AI channel can reach up to 200 kilohertz, is suitable for high-speed data acquisition of various mechanical, electronic, and physical signals in industrial production, automatic control, electrochemistry, medicine, etc. And again, this module uses PoE, which means that you can power it with an external data source, or you can power it using the same cable that you use for data transmission. Okay. Okay, and now we're going to talk about a quick application example using the PET7H16M. So the SG3000 series signal conditioning module can be connected to a variety of sensors for current, voltage, thermocouple, resistance, or temperature sensors, resistance temperature sensors. Strain gauge, accelerometer, different input signals such as IEPE accelerometer, filtered, isolated, amplified, and converted into an analog voltage or current output in the general measurement range. PET7H16M plus SG3000 series signal conditioning module not only monitor voltage, current, temperature, strain, vibration, and other diversified signals, but also collect real-time data from different regions and transmit it to the central management system over Ethernet. Another application example of this module would be in a high voltage and high current speed measurement application. For instance, we have a sensor called the DN800 series, which is a voltage attenuator and current transformer designed for use in high voltage and high current applications. The high voltage and high current can be converted into plus or minus 10 VPP attenuated signal, and PET7H16M is able to read plus or minus 10 volt DC signals via DN800 series. By using the DN800 and PET7H16 together, the power data of all kinds of machines and AC/DC motors can be measured at a high speed and retrieved and then analyzed and quickly used to develop a model for a failure warning system. Okay, so now we're going to talk about some specific features of the PET7H16M. It comes on board with a number of modes. For use, the first mode is the data transmission mode or continuous transmission. It also has an AD trigger mode, external digital signal event trigger mode, AD sync trigger between multiple modules. It also has a built-in web server for easy configuration that you can access from just a regular web browser. And again, it uses the Modbus TCP protocol, which we discussed earlier, giving it a number of advantages. To talk a little bit about PoE, the P in PET7H16 stands for its PoE function. The PET7H16M series module has integrated power over Ethernet. It allows power and data to be carried over a single Ethernet cable, so any device can operate solely from the power it receives through the data cable. This innovation allows greater flexibility in office design, higher efficiency in systems design, and faster turnaround time in setup and implementation. The PET7H16M series features true IEEE 802.3AF compliant PoE standard, using both Ethernet pairs in addition to the PoE-enabled network. This is a desirable feature when the total system power requirements exceed the power source's load capacity. Furthermore, with the auxiliary power option, PET7H16M can be used in a standard Ethernet or a non-PoE system. When using PoE devices like this one, you can choose the ICPDAS PoE switch. The NS205 PSE is the power source. The NS205 PSE automatically detects the connected devices and whether they are PoE or not. This mechanism ensures NS205 PSE to work with both PoE and non-PoE devices coordinately at the same time. Being a power source for PoE, NS205 does require an external power source. Okay. Let's see, was there anything more that I wanted to say about the PET7H16? Just to summarize, the PET7H16 is a high-speed data acquisition module, the built-in Ethernet communication port for data transfer over a network. and includes multiple high-speed analog input channels with a FIFO of 2048 samples with a maximum sampling rate of up to 200 kilosamples per second, with 16-bit AD converters simultaneously sampling on each channel. In addition to the analog input channels, various I/O components, your digital input and output channels, are mixed with multiple channels in an I/O module. The module provides a programmable input range on all input channels, and the digital output can be set to output with short circuit and overload protection. The PET7H16M series also provides 4 kilovolt ESD protection, as well as 2500 VDC intermodule isolation. PET7H16M supports more kinds of trigger modes for AD conversion. It has a software AD trigger, external clock trigger, external digital signal event trigger, which is a post-trigger pre-trigger. A software trigger can acquire a sample whenever needed, and the continuous AD acquisition, or the acquisition of N data samples, begins after the command is triggered. In external clock trigger mode, the speed of the AD acquisition and the amount of data acquired are controlled by external electrical signals. In digital signal event trigger mode, the AD acquisition parameters are configured via a command, and the analog digital acquisition of the N data samples is started while triggered by an external electrical signal. Okay, that about wraps it up for the PET7H16M. At this time, I'm going to go ahead and answer any questions that you might have. Please feel free to enter them into the chat box now. If you have any questions about this specific module or about Modbus TCP, PoE, or Ethernet data acquisition in general, I'd be happy to answer those for you. Okay, seeing as there are no more questions at this time, we're going to go ahead and wrap it up. Oh, there's one. Let's see, we have a question. This module is indicated with 8 single-ended inputs. Does PET7H16M support expansion cards? I don't believe it. Since it's just a standalone I/O module, I don't think it supports an expansion card. However, I might refer you to Steve to answer that question. Steve, do you have an answer for us? Or Robert? Robert, do you have an answer for us? Okay. That's right. Robert is just confirming that it doesn't accept expansion cards. It's just a standalone I/O module. Okay, and in answer to another question, all inputs are single-ended, so yes, it's 8 single-ended inputs, not differential. Another question, does it support i7000 modules? No, again, this is an I/O module, not a controller, so it doesn't support the i7000 modules. Okay, good questions, everybody. But looks like that is about it. So thank you very much for your time. Thank you for attending. I hope you learned a little bit of something. If you have any Further questions, comments, you'd like to learn a little bit more about the products, our contact info is on the screen. Go ahead, shoot us an email, give us a call. Yes, again, thank you very much for attending. Have a great Friday, everybody.